Today we are working on permutations. Permutations are arrangements where order matters. And we use factorials to find permutation. So factorial is taking all of the positive integers down to 1 and multiplying together. So what I mean by that is for 5 factorial, we would take 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. Now, most of you, especially once you get to larger numbers, aren't going to want to have to multiply that out every single time. So this next one, 7 factorial, where is the exclamation mark? So one of the options is down here, it's the G, and going over the exclamation mark. So 7 factorial, so 7 times 6 times 5 times 4 times 3 times 2 times 1 is 5,040. And then 4 factorial is 24. So our first example, a student council member. Our student council members have selected 10 students to choose from filled positions of president, vice president, secretary, and treasurer. Each student can only fill one position. How many different outcomes are possible? Okay, so we have 4 places to fill. We have president, vice president, secretary, and treasurer. And each student can only fill one position, so we cannot repeat. So that means for president, we have 10 options. But once we choose president, there's only 9 people left to choose from for vice president. And once we choose vice president, there's only 8 people left to choose from secretary. And once we choose secretary, there's only 7 people left to choose from for treasurer position. So 10 times 9 times 8 times 7. And that gets us 5,040 possible outcomes. Next up, we're going to look at probability. So probability is the number of outcomes in an event over your number of outcomes in your sample space. We can also call this part over the whole. So the part that we're looking at over all of the possible outcomes. So our next set of examples, we are looking at a standard deck of playing cards, which contains 52 cards, 13 of which are spades, they're black, 13 of which are hearts, and they're red, 13 which are clubs, and they're black, and 13 which are diamonds, and they are red. So the first one, we want to find the probability of drawing a spade. So our number of spades is 13 over our total number of cards, which is 52. Now, you do need to make sure you reduce fractions. So can we reduce 13 52nds? You don't know off the top of your head, your calculator, see if it reduces. It does. It reduces to 1/4. Next up, what is the probability of drawing a club or a diamond? So clubs, we have 13 of them. Diamonds, we also have 13 of them. We're going to add those together over our whole, which is 52. So a club or a diamond, that's why we can add it, because it doesn't say and, meaning that it's two separate events. So 13 plus 13 is 26 over 52, and that reduces to 1/2. So the probability of drawing a club or a diamond is 1/2. So then our next one, we want to find what the probability of drawing a red card is. So probability of a red card. So what all are reds? Not spades. Hearts are red, so there's 13 hearts. Not clubs. Diamonds are red. So we can add those together. 13 plus 13 over our whole, which is 52. So we get 26 52nds, which reduces to 1/2. So the probability of drawing a red card is 1/2. And then the next one, what is the probability of drawing a blank card? So we have 13 spades, 13 hearts, 13 clubs, and 13 diamonds. It's a total of 52 cards. None of those are blank. So we can't draw a blank card. So there's no way to draw a blank card out of 52. So that probability is 0. Next up, a student ID has 5 digits selected from 10 possible digits, 0 through 9. Assumed digits cannot be repeated. That's important. We cannot repeat digits. How many possible ID cards can be made? So we have 5 digits that we're selecting. So we have 5 spaces. And for the first one, we have 10 possible digits to choose from, but we can't repeat. So once we use the first one, we can't use it again. So let's say the first number is 6. There's only 9 possible options left. So we have 9 to choose from for the next one. Let's say it's a 2. That leaves us with 8 possible options left. Once we pull that, let's say it's a 9. That leaves us with 7 possible options left for our next one. Once we draw that, that only leaves us with 6 possible options. So we've got 10 times 9 times 8 times 7 times 6. And we get 30,240 possible different ID number, 5-digit ID numbers. Our next one, we want to find the probability that a randomly selected ID card has the ID number 45362. Okay, so if this is the ID number, then there's only one ID that can have it. So our probability is 1 in 30,240. And that as a decimal is 0.000033. And if we were changing that to a percent, remember you move your decimal over 2 times to the right. So that would be 0.0033%. Okay, so now we're going to talk more about permutations. So permutations are ordered arrangements where R is less than or equal to in your number of objects selected without replacement from your in number of objects. So this formula here, n factorial over n minus r factorial, is our formula for permutation. Now, it is the same thing as what we've been working on. So if I take and have 10 students to choose from, and I'm choosing 4 of them, I'm going to have 4 spots. We can't replace them, so we'd have 10 times 9 times 8 times 7. Which is 5,040 possible outcomes. So yes, you could use your formula here, but I would much rather you write out your blanks and fill in your blanks. Our next one, let's say you have 10 digits to choose from, and you're choosing 5 of the digits. So we've got 5 spaces to choose from. And again, we can't replace. We've got 10 times 9 times 8 times 7 times 6, which gets us 30,240 possible outcomes. Okay, so all of those were drawing without replacement and where order matters. Next up, we are looking at permutations with repetitions. So we have repeated numbers or letters that we need to deal with. So one of the most common problems, which is what these are named after, is the Mississippi problem. So on a game show, you are given the following letters and asked to unscramble them to name a U.S. river. If you selected a permutation of these letters at random, what is the probability that they would spell the correct answer of Mississippi? So first off, we need to find in our total number of letters. So in Mississippi, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. Then we need to find all the letters that appear more than once. So M only appears once, not worried about M. I, that's 1, 2, 3, 4 times that we see it. S, see 1, 2, 3, 4 times. and we see P twice. So we take our total number in, which is 11 factorial, over all of our repeats factorial multiplied together. And so 4 factorial times 4 factorial times 2 factorial. So I do highly recommend using the control divide feature if you're on Inspire, because you need to make sure that the 4 factorial, and 2 factorial are all in the denominator. So control divide, 11 factorial, narrow down, 4 factorial, 4 factorial, 2 factorial. And we get 34,650. And that's a number of different possible ways we can spell the word Mississippi, or arrange the letters in the word Mississippi. But we weren't looking for how many different ways we can arrange the letters in Mississippi. We were looking for the probability of getting correct answer of Mississippi. So there's only one way to correctly spell the word Mississippi. So our probability is 1 out of 34,650.